Video, we will go over / review sequences, series, and go over the term convergence and divergence. Factorial, monotonic, bounded, and infinite. We'll just kind of like review. We will go over the difference between a sequence and series. Finally, we'll learn how to generate general terms and simplify factorials for both finite and infinite sequence and series. Then we will determine whether or not a sequence converges or diverges using the nth term test for the sequence, and we will go over an acronym riddle for memorizing the series test. So you probably learned about sequence and series back in pre-calculus, but let's kind of review. So what is a sequence? It's a listing of numbers, and they close it with this weird bracket thingy. So an example would be like 1, 2, 3, 4. They're all sequences, right? They're numbers. And they can be finite or infinite. So a finite has an endpoint, infinite can go infinity. So maybe you might see like 1, 3, 5, 7, and then dot dot dot. That means it goes on forever. Okay. A series is a sum of these numbers. So imagine, for example, imagine adding up all these numbers, 1, 2, 3, 4, 5, that will give us your sum. So that is the same thing with this. A series is a sum of numbers, and it has this little weird e. Excuse me. And so yeah, this little e symbol means series, and uh, this number here is your starting point, and then this number here is your ending point. Okay. Excuse me. So if you look at this series, um, we have to start at 2, and then we end at the 10th term, and you just add them up. Okay, so let's talk about converges. So if the term gets closer to a number, then it converges. Uh, yeah, series is the sum of all numbers. And if a sequence converges to 0, and if it doesn't go to a number, so if the sequence goes to a positive infinity or a negative infinity, it usually diverges. So right, that I just explained that. Diverges is a term do not approach to a number. So yeah, and basically it either becomes infinity or negative infinity. That's how you know it diverges. And you might have seen this again in pre-cal factorial. You see this a number and like for example a 5 and then this exclamation mark. Well, that exclamation mark is a factorial. And what does that really mean? So for example, 5 factorial, it just means 5 times 4 times 3 times 2 times 1, and then you multiply it all together and you get 120. That's all it means. And then you just have to remember 0 factorial is just 1. So let's do the first example. It says write the first 5 terms of the infinite sequence. So infinite means to infinity, right? So they only want the first term. So here's our nth formula. An equals parentheses -1 raised to n times n over n plus 1, right? So let's first find first term, a1. So wherever you see an n, just replace it with 1. So this is going to be -1 raised to the 1. And then this is going to be 1 over 1 plus 1. And this is going to be -1 times 1 is -1. And then 1 plus 1 is 2. So that's -1/2. And then a2 is going to be -1, and then just replace it with 2. So this is going to be 1 or 2 over 2 plus 1. -1 squared is +1. This is 2. And then over here, 2 plus 1 is 3. So what's 1 times 2/3? +2/3. Okay, third term is -1 to the third. and then it's going to be 3 over 3 plus 1. So negative 1 to the third is negative 1. And then it's going to be 3. 3 plus 1 is 4. Put it all together, negative 1 times 3/4 is negative 3/4. Keep going. How about the fourth term? That's negative 1 to the fourth. And then this is going to be 4. And then 4 plus 1. Negative 1 to the fourth is positive 1. And then it's going to be 4 over 4 plus 1 is 5. So what's 1 times 4/5? 4/5. And the fifth term would be negative 1 raised to the fifth. And then this is going to be 5 over 5 plus 1 equals to negative 1 to the fifth is negative 1. And then this is going to be 5 over 5 plus 1 is 6. What's negative 1 times 5/5? Negative 1 times 5/6 is negative 5/6. And then you can just write your final answer as this. You put this weird bracket, and that's going to be negative 1/2, 2/3, negative 3/4, 4/5, negative 5/6. And then you close it with a bracket. Okay, so that's how you can write out the first 5 terms. Yeah. Okay. Let's do example 2. Same idea, write out your first 5 term. Your nth formula is an equals n factorial over n. So first up, let's find first term. So it's going to be replace n with 1. So it's just going to be 1 factorial over 1. And 1 factorial is 1 times 1 over 1. And we know that 1 times 1 is 1 over 1, which is 1. And then the second term would be 2 factorial over 2. What is 2 factorial? 2 times 1 over 2. 2 times 1 is 2 over 2. And I made a mistake. This should be positive 1, right? Okay, third term. It'll be 3 factorial over 3. So what is 3 factorial? 3 times 2 times 1 all over 3. And do you see anything that cancels? Yes, the 3's. So you're left with 2 times 1, which is just 2. Okay, the fourth term would be 4 factorial over 4. And then 4 factorial is 4 times 3 times 2 times 1 all over 4. And then do you see something that cancels? Yes, the 4's. So you're just left with 3 times 2 times 1, that's 6. And then the fifth term is 5 factorial over 5. So 5 factorial is 5 times 4 times 3 times 2 times 1 all over 5. And then do you see something that cancels? Yes, the 5's. And then when you put it all together, what's 4 times 3 times 2 times 1? That is 24. Okay, and then you can put your final answer at like this bracket. And our first term is 1, our second term is 1, our third term is 2, my third term is 6, and my last term is 24. Okay, the next one. So this one says simplify each factorial expression. Okay, so let's start with one. We have 4 factorial over 6 factorial. So that's like saying 4 times 3 times 2 times 1. And then on the bottom, it's just 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. And then you have, do you see anything that cancels before we can, yeah, we can get rid of this 3, 2, and 1 because on the bottom there's a 3, 2, 1. So you can cancel this 3, can out this 2, can out this 1. And then on the top you're left with 4. And then on the bottom you're left with 6 times 5 times 4, which is 30. No, it's not 30. 6 times 5 times 4 is 120, but it can be reduced by 4, and that gives you 1 over 30. Okay, let's move on to number 2. We have n minus 1 factorial over n factorial. So how do we do this one? Uh, did you know that n factorial, we don't have enough, we can't just plug in a number for n, right? Because it just says n minus 1 factorial over n factorial. But did you know that n factorial is the same thing as n times n minus 1 times n minus 2, and then dot, 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 right? And then, did you also know that 2n factorial is the same thing as 2n times 2n minus 1 times 2n minus 2, dot, dot, dot. So on the top, 2n, on the top, n minus 1 factorial will be like n minus 1 times n minus, so what's a, you keep subtracting one number, so what's negative 1 minus 1? Negative 2. And then on the bottom, we could keep on going, right? We could do n minus 3, but I have a feeling we could stop there because n factorial would be like n times n minus 1 times n minus 2, and then everything else cancels. So you can just stop here, and yeah, you can stop here, and then you can, as you can see, the n minus 2 cancels, and then this n minus 1 cancels. So really now you're just left with 1 over n. Okay, we can move on. So let's move on to example 3. We have 2n plus 1 factorial over 2n minus 1 factorial. So from the previous examples, we know that the numerator factorial would be expressed as 2n plus 1 times 2n plus 1 minus 1. Really, that just really is just n, 2n. And then it's 2n plus 1, or so it's plus 1 minus 1, wait, minus 1. So that's really that just becomes negative 1. And then 2n plus 1 minus 1 minus 1 minus 1. And then On the bottom, it's almost the same thing. It's like 2n minus 1 times 2n minus 1 minus 1, 2n minus 1 minus 1 minus 1, etc. So let's see if we can clean this up. So over here, plus 1 and negative 1, I kind of canceled. That's just 2 cancels. And then over here, what does this simplify as? 2n plus 1 minus 1 is 0, and then you have this negative 1. Over here, we have 2n plus 1, negative 1 cancels, and then negative 1 minus negative 1 is negative 2. And then over here, you have 2n. And then over here, let's see here. This is just 2n minus 1. This is going to be 2n minus 2. This is going to be 2n minus 3. So this is where you can start canceling. What can we cancel? This one. And everything else cancels. If you continue the top, it would be 2n minus 3, right? And this would cancel, and then this would cancel. So on the top, everything on the bottom cancels. So on the top, we're left with 2n plus 1 times it by 2n. And that is your final answer. Okay. So now let's talk about nth term test, divergence test for sequence. So nth term test, divergence test for sequence. So if the limit as n approaches infinity of a of n equals the limit is tangible, then an converges, right? So basically, if it comes out as a number, a real number, it converges. And if the limit as n approaches positive infinity of a of n equals infinity or undefined or also negative infinity, then it diverges. So if the number comes to if the limit becomes positive infinity or negative infinity or undefined, then it diverges. If the limit actually becomes an actual value, it converges. So example 1. Determine if the sequence converges or diverges. So we have the limit. So let's rewrite this as the limit as n approaches infinity. Now, what kind of function is this? N squared plus 7 all over n squared. What kind of function is that? That is a rational function. And how do you find the limit as a rational function? It's basically your horizontal asymptote, right? So you need to know your 3 rules of your horizontal asymptote. Yeah, what are the 3 rules? So you look at the highest term on the numerator. You pick the highest term on the numerator and the highest term on the denominator, and then you apply your 3 rules. So the highest term on the numerator is n squared. And then the highest term on the bottom is n squared. So as you can see, look at the degrees. What do we know about when the degrees are the same? We use the coefficient. So this top has a coefficient of 1, and then this has a coefficient of 1. So your limit is just 1. And it's an actual value, so it converges. Let's move on to example 2. So we have n squared minus 3 all over 2n plus 1. So we're trying to find the limit of this. I mean, we're trying to figure out if this value converges or not, if as x goes to infinity. And what do we know about this function? We know that this is a rational function. So pick the highest term on the numerator, which is n squared. Pick the highest term on the bottom, which is 2n, or 2n to the power 1. So what do we know when it is like this, when it's top heavy of a rational function? We know that it is no longer, you no longer have a horizontal, you have an oblique. And you have to do long division. And what do you usually get as an oblique asymptote? You get a linear function, right? You get y equals mx plus b. And what is a what is a limit as a linear function, right? Um, I'm not going to do the long division, but you can if you want. So if you did, what would it be? You have n squared here, and then you have a 0 n minus 3. Here you have 2n plus 1. Yeah, it's going to be linear in probably going to be 1/2. 1/2, and yeah, it's a linear function, and it doesn't matter. So what does linear function look like? They can either go positive or they can go negative. So yeah, it's going to be either so it doesn't matter if it's going positive or negative. What is the limit of a linear function? It's infinity, right? It's going to be infinity. And what do we know about infinities? It's not a real number, so it's going to be diverge. Okay, let's move on to example 3. So we have 2 over 2 to the n. So maybe I don't know what this type of function is. I really don't think it's a rational function. I don't think it's a linear or exponential, but what if I just plug in my n value for infinity? So it's 2 over 2 to infinity. And what is this going to be? So it's going to be 2 on the top. And then what's 2 raised to a very, very large number? It's infinity, right? 2 raised to infinity is usually infinity. Now ask yourself, what is 2 over infinity, or 2 over a very large number, or 2 over a very small number? 2 over a very large number gets very close to 0. And what is 0? A real number, so it converge. Okay, let's move on to example 4. We have parentheses n minus 1 factorial over n factorial. Uh, we, we cannot evaluate this until you get rid of that factorial first, right? So we cannot until you get rid of factorial. Okay, so it's going to be, let's get rid of that factorial. So it's going to be the limit as n approaches infinity. And then on the top, it's n minus factorial. So it's going to be n minus 1 times n minus 2 dot 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 1. And then on the bottom, what's n factorial? It is n times n minus 1 times n minus 2 dot dot dot, because we don't know. But the good news is, what do you see that cancels? So we don't have to keep on going because everything else cancels. So the n minus 1 cancels, the n minus 2 cancels, and then on the top, you're just left with 1 over n. Now go ahead and put your infinity into n. So it's 1 over infinity. What is 1 over infinity? it is 0, or 1 over a very large number is 0. 0 is a real number, so it converges. Okay, let's move on to example 5. So we have, I don't know what this is. Like, what kind of, oh, this is a cosine graph. Yeah, so we can rewrite this as the limit as n approaches infinity of cosine of pi n over 2. And we know this is a cosine graph, and cosine graphs, so it might look like this. It's a cosine graph. It goes to max, min, max, min, max, min, right? So as x goes to infinity, the y value just keeps on going to infinity as well. So this is going to be infinity, or it's just going to be diverge. Okay, let's move on to determining converge slash diverge for infinite series. So this is just, there's later on, there's just a lot more rules or a lot more tests we can do to determine if it converges or diverges. And so you have what's called the nth term test, the P series test, the geometric series test, the comparison test, the integral test, the telescoping series test, the alternating series test, the ratio test, the root test, and then you can just use this riddle NPGCITARR. So that's like that little, you can just use this riddle to remember convert or diverse for infinite series. So it is NPGCITARR, or you can think of it as nice. Remember the King Henry drink chocolate milk? It's very similar to this, but it's going to be nice penguins go camping in the Arctic R region. Okay. And we will continue on converge diversity test. Okay. So the next test we will go over is the nth term test. Okay, so I hope you learned a lot in this video, so we will continue. We will stop here.